Okay, today we're going to finish talking about regression. So, started off, if we go back to the beginning here, talking about that correlation coefficient R and how to set that, and that is to turn that diagnostics on, which is second catalog. Once you do that, it should be on for good, so you shouldn't have to worry about it. Then from there, it's looking at the best fit line, and you're not going to have to be responsible for regression except for linear, exponential, logarithmic, and power. And usually they will tell you. And then here's the steps on your calculator to look at a scatter plot and to get the regression equation. So make sure you take a look at these. Even if you have, I changed it around, so if you have the new operating system, you're going to be putting L1 and X list, L2 and Y list, and you go to vars, Y vars function, Y1 to store the regression equation. And then again, it just goes through exponential, how to do that, and how to do logarithmic regression. So back to exponential for a second. We are going to be looking for EXP-reg and stat calc. For logarithmic, we are looking for LN-reg. And for power, we're looking for PWR-reg. Okay, and linear, it's lin-reg choice 4. So the examples for this course are, again, linear, exponential, logarithmic, and power. So we're now going to talk about interpolation and extrapolation. So interpolation is the process of finding a function value between the given values. Extrapolation is when you have your data, but maybe you want to make predictions outside of your range of data. Sometimes extrapolation may not always be accurate because something that happened so many years ago and then you're going to predict the future, a lot of things could have changed. So it really works best to try to hold them as close to between the range of data points or slightly outside of the data points that you already have. You can do interpolation and extrapolation on your calculator. So for extrapolation, if you're given the X, you enlarge your window, possibly to accommodate the needed data, and then you can do second trace value, which is also second calc value, and go X equals, type in the X value, and you'll get a Y. For finding the X, given a Y, you go to your window, your Y1 values, and you type in Y2, and you find intersections. So we did a linear example and wrote out calculator steps to find all of that information about the correlation coefficient, the equation, how to set your window to find a Y value given an X, and how to do the, when you have Y given, how to find the X. So that was a linear regression equation. Let's try another one. So this next one, we're going to round our coefficients to 3 decimal places. We're talking about a car. And the value of the car at T years, which was the year 2000, and then after that, how the car depreciates. So first thing they want you to do is to find an exponential regression equation that models this data. So we'll go to the calculator itself and go to our stat, edit, and clear out these lists. And type in 0, 1, 2, 4, 8. And in L2, we will have 4,000. 3,400, 2,890, 2,088, and 1090. Now some kids have trouble figuring out which should go in L1 and which should go in L2. Well, whenever you are dealing with like years and values, years are always on the x-axis. They are always the independent value. The value depends on the year. So L1 is representing the x kind of, and L2 is representing the y. So year is x and value is y. So L1 and L2. So let's get our equation first. So we'll go to Stat, Calc, and you need to find exp reg. They told you in the question to do exponential reg, so I believe that it is 0. We've already done exp reg in an earlier chapter. You need to tell it L1, comma, L2, or if you have the other one, you need to put that L1, comma, L2 into your X list, Y list, yeah, X list, Y. Make sure the frequency list on the new operating systems, make sure the frequency list is empty. And then we're also going to do comma while we're here, vars, Y vars, function, Y1. And we'll store the equation as well. So when we hit enter, there's our equation for our exponential. So to the nearest 3 decimal places, 0.970 at the end of the 3999.970 times 0.850 to the x. So y equals 3999.970 times 0.85 to the x. So my calculator steps were stat, edit, stat, calc, exp reg. Because on the Regents exam you're asked to show some work. Your calculator steps can serve that purpose. There's your work. Okay, to the nearest dollar, predict the value of the car 10 years after its purchase date. Okay, so let's go back and take a look at this. So if I go to second y equals, I want my plot to be on. I want a scatter plot to be on. So, and I want the x list and y list to say L1 and L2, and they do. So now, and if I go to y equals, just plain old y equals, I already have the equation there because I put it in there using the vars. And then if I go to zoom and I want to graph this, I want to do a zoom stat, which is number 9. And that will draw the scatter plot and the best fit curve. And boy, does that look like it goes through the points really well. So now we need to have that drawn in to predict the value of the car 10 years after its purchase. So 10 years after its purchase would be when x is equal to 10. Or would it be when x is equal to 9? Because actually, yeah, 10 years after. So we'll go with 10. So if you go to your window and you want to find something where the x is going to have to be 10, look at that x max. That x max is 8.8. You better make that larger. So maybe make it 12. And then you can go to second trace value. It will draw the graph in for you, and then it will say x equals, you put the 10 in. If you don't expand that window, it will probably say some sort of dimensional error. And there's our answer. So to the nearest dollar, $788. So what we did here was we went to second y equals to make sure the plot was on. And then we did, after that, once the plot was on, we went to zoom stat, and we saw our graph. And then we went to the window, and we changed the x max to 12. And then we did second trace or calc value. And when it came up with x equals, we put 10 in, and we got y is equal to 787.52, and we want that to be to the nearest dollar, so 788. B, to the nearest year, predict the year the car will be worth 2,000. So that's going to, again, take us back to the calculator. In this case, I am looking for the x, I know the y. So 2,000 goes into y2. Now, when you go to your window, you better make sure that your y max accommodates 2,000. It does. Your y min, it's between there. So we should just be able to hit graph, and we're looking for the intersection. So it's second trace intersect. And the intersection is 4.265, and they want it to the nearest year, so 4 years. So for this one, we went to y equals, and in y2, we put 2,000, and we hit graph, and we can see the intersection, so we didn't need to change the window. So then we did second trace intersect. And when y was equal to 2,000, x was 4.2 something, 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 and to the nearest year, it was 4 years. All right. Next, a savings account initially has a balance of 500. The number of years that the money must be in the account for it to grow to a balance of $B is shown in the accompanying table. Determine a logarithmic regression equation that models this data. Okay, so I know I talked about years, but this is going to be the balance is x and the years is y. Okay? A savings account initially has a balance of 500. So if we would put this into like a growth model, it would be A equals principal, so as a balance of 500 would be the amount you'd put in for an x. And it would come out the number of years t that the money must be in the account for it to grow to a balance. Well, you'll see when we get there the equation. So first thing it says is determine the equation, so let's do that. So back to stat, edit, so 500, 1,000. L2, 0, 13.9, 21.9. You could probably pause, and fast forward through this part of me entering that data in. All right, so I'm going to go to stat, calc. Now, it said a logarithmic Okay, use a logarithmic. So the logarithmic is ln. We have to arrow down to it. There it is, number 9. And tell it L1, L2, comma, vars, y vars function. If we need this, then it's in there. The scatter plot should already be set up from the last one, so we should be good to go with that too. So here's the equation, all right, ln. It's not using log, it's using ln. So go back and write that. So y equals to 3 decimal places, okay, and then my calculator steps were again stat, edit, and I listed L1 and L2, and then we did stat, calc, ln, reg, okay? So now if I go down here, it says use the regression equation found. So that means use the rounded one, okay? To predict to the nearest tenth of a year the number of years the money must be left in the account for it to grow to a balance of 7,500. So again, they're giving you the x, which is the 7,500, and they're looking for the y. So I'm going to go back here, and since I'm using the regression equation that I found, the rounded one, I'm going to clear this y1 out, and I'm going to type in the rounded one, because that's what they said to do. Sometimes it makes a difference and sometimes it doesn't. And I don't need the 2000 in there anymore. And I should be good with zoom 9. Well, look at that. It goes through very nicely, even using my rounded equation. So I'm looking for when the balance is going to, the year for the balance to grow to 7,500. So I need to check my window. My x value is not going to accommodate, so let's try 8,000 and hit graph. Okay, and then second trace value, 7,500, and there it is. It's going to take 54.1 years for it to grow to that. That should make sense, and it does. So y equals 54.1 years. So a little work here. We did y1 equals negative 124.250 plus 19.993 ln x. We changed the x max to 8,000 and then did second trace or calc value, and we plugged in x equals 7,500 and we found y. Now on part B, again using the regression equation found, predict to the nearest dollar the amount of money in the account after 45 years. So now I am looking for the x, and I know the y is 45 years. So for this one, I'm going to go back again, and I'm going to put in y2 equals 45. I already have the equation in there. So y2 equals 45, and I'm going to hit graph and see if I can see the intersection, so I do not need to change the window. So second trace intersect, enter, 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 and it intersects at 4,748 dollars to the nearest dollar, they said. The 0.9 rounds that up. 4747.9 rounds that up. So y2 equals 45. We hit graph. And then we did second trace intersect. Okay, so second trace intersect, and the x value was $4,748 to the nearest dollar. Now, it says find the answer using only the calculator and the non-rounded regression equation. So we'll go back in here and we'll go to stat, calc. I got to go find that. I got to re-enter this. Okay. Okay, so there we go. Second 1, comma, second 2, comma, vars, y vars, function, y1, enter. So now that regression equation is stored back in there. And now when I do y2 equals 45, I think I changed my window a bit, but that's fine. So I'll do second trace intersect and see if there's any difference. Sometimes there's a lot of difference, other times not much. So we had 4,747.9 doing it with the rounded equation. This one's 4,748.1. So they're about the same. If it had been a little bit different, the rounding might have been a problem. So in this case, we went back in and we did ln reg, and we did L1, comma, L2, comma, Y1. And I did, again, I just did second trace intersect, because the 45 is already in there, and we got x was, it was 4748.1 versus the one up above was 4747.9. So there was a little bit of a difference. All right, next one. Last one. On the surface of, on the mysterious planet Matho, the weight W of an object and the distance d this object is from the surface of the planet were recorded and are shown in the accompanying table. So this is going to be L1 and L2, x and y. Weight is measured in pounds and distance in miles. Find a power regression. So now we need to go find a power regression equation. So go back to stat and edit again. And 2, 3, 4, 5, 6. Okay, so stat, calc, power regression. There it is, PWR regression. It's A, choice A. So second 1, comma, second 2, comma, vars, y vars, function. Y1, if I need it. I may not need it. I may type in my own. There's my equation. Okay, so it's telling me it's power, so I'm good. So my equation rounded to 3 decimal places is 377.336x to the negative 1.702. Okay, so if we look back there, okay, you do not write out all those symbols you need to be able to go right to the equation. The calculator steps for this one were stat, edit, and then stat, calc, and then we did PWR regression, which was A. Okay, so again it says using the regression equation found, find the predicted weight. So what I'm going to do is go back here, because I might be asked that same question. I'm just going to turn this one off for a second, and I'm going to clear this. 45, and I'm going to type this one in by hand here. So 377.336 x to the negative 1.702. Okay, so now I've got that entered in there. And find to the nearest pound when it is 20 miles from the surface of Mathos. So 20 miles is the distance, so that would be the x. So I'm going to go to my Zoom 9 and get my plot. You have to have this plot before you, and this is the equation that I just put into y2, the rounded one. And then check that window out. And I'm going to be putting in d is equal to 20, so the x max needs to change to like 25. And I'm going to do second trace value. And it's going to let me type in 20 because now I've accommodated my window. And my y is 2, it says find it to the nearest pound. It's 2.3, so it's 2 pounds. So, again, what I did there was I went and I got my stat plot. So I went to y1 and I typed in 377.336x caret negative 1.702. And then I did Zoom 9 to take a look at it. Then I went to the window, then I changed the x max to 25, and then I did second trace value, and when it came up with x equals, I put in 20, and the value of y to the nearest pound was 2. So this was number 1, 2, 3, 4, and then I got my value. Using this same regression, find the predicted distance to the nearest tenth. What is the distance from the surface when the weight of an object on Matho is 30 pounds? So now I'm going to do y2 equals 30, and I will check the window on the graph. So let's go do that. So actually I'm going to put y3, but you can just put this all into y1 and y2, and we can re-enter that original y1 equation. So 30, and if I look at my window, I have to have, and my y-min looks like it accommodates 30, so second trace intersect, and enter, enter, enter. So when it's 30, the x value, the distance is to the nearest tenth, 4.4. So y2 equals 30, and then I check the window, and then I hit graph, and then I did second trace intersect. And I found my value. So this was step 2, step 3, and step 4, x was equal to 4.4, and this would have been, there were miles. And then find the answer to part B using only the calculator. See if there's much of a difference between the rounded answers. So the one we just did, that's why I kept that into y1. So now I'm just going to turn on y1 and turn off y2. You just go over the equal sign and you hit enter. So I'm turning that off, and then when I hit graph, we should still see the intersection. So we'll do second trace, intersect, enter, enter, enter. And this is 4.4 also, so not much of a difference. Sometimes there is, and so it does make a difference depending on the problem. So in this instance, you would recalculate, so you would go back to stat, calc, power reg, and you would do L1, comma, L2, comma, put that Y1 back in there, and then from there you would do second trace intersect. And we still get x is 4.4. So there was really not much of a difference. 4.42, I don't remember what the other one was, but it wasn't, I think it was very similar to it. So those are basically the same. Alrighty, and that's it. Thanks.